In part 2 of our lesson on recursion in Java, we're going to look at how to solve a factorial recursively and then how to trace out that algorithm. First, some information on factorials. A factorial is an integer multiplied by all positive integers below it. Both 0 factorial and 1 factorial are equal to 1. Factorials can be calculated either iteratively or recursively. In this case, we're going to study how to do it recursively. Let's look at an example of a factorial. 5 factorial is equal to 5 times 4 times 3 times 2 times 1. We could also say 5 factorial is equal to 5 times 4 factorial. In this case, we're taking a recursive approach by making a smaller version of our original algorithm. Next, we're saying 4 factorial equals 4 times 3 factorial, which is again even a smaller application of our original algorithm. Then 3 factorial equals 3 times 2 factorial, 2 factorial equals 2 times 1 factorial, and then 1 factorial is our base case, which simply equals 1. Let's write out some code to solve this recursively in Java. First, we're making a method, fact, that takes in an integer parameter. Here's our base case. If the num is 0 or 1, we return 1. If 0 factorial or 1 factorial is 1. And this is our base case because it does not call itself. Next, we have our recursive case, where we multiply the number times the factorial of 1 less than the current number. This is our recursive case because we are calling the same method again, but passing it a smaller problem this time. Here we've created our main method so we can call our recursive method fact. In this case, we're going to system out print line whatever is returned by fact when we pass it the argument 5. So on the stack, we place fact 5, which is our first call, and we say that's going to return 5 times fact 5 minus 1, which is 4. Next, we calculate fact 4 will return 4 times fact num minus 1, which is 3. Fact 3 will return 3 times fact num minus 1, which is 2. Fact 2 returns 2 times num minus 1, which is 1. And finally, fact 1, when we pass 1 to the parameter, we go to our base case and simply return 1. Now we're going to plug these things in as we pop items off the stack. So we know fact 1 returns 1. So we cross this out, put in the 1, and we pop the top thing off the stack. Next, we calculate 2 times 1 is 2. So fact 2 will return 2. Pop this off the stack, and then replace the 2 with our call to fact 2. Next, we calculate that 3 times 2 is 6, so we know fact 3 will return 6. Pop that off the stack and plug in the 6. 4 times 6 is 24, so we know fact 4 will return 24. We know replace the fact 4 with the 24. 24 times 5 is 120. So we know the number 120 gets returned to our main method, which will be outputted. Some important additional information to know about recursion. There is a finite amount of room in the stack. Therefore, we have to be careful to use algorithms that won't fill our stack above capacity. If the stack gets full, it will lead to a stack overflow, which will cause our Java program to crash. Stack overflows can happen when we accidentally create an infinite loop where the same method gets called over and over again till the stack runs out of space. We can also run out of space in the stack if we try to use an algorithm that will make too many recursive calls and will fill up the stack. Recursive calls should move the program closer to the base case. If it doesn't move it closer to the base case, we will eventually run out of space in our stack and get a stack overflow. To see the next video in this curriculum, please click on the link in the lower left-hand corner of the screen. To see the entire curriculum, please click on the link in the lower right-hand corner of the screen.